So this is the question number 46 in GATE 2014 and it came in set 1. So the question says the 16 mld of water is flowing through a 2.5 kilometer long pipe of diameter 45 centimeter. The chlorine at a rate of 32 kg per day is applied at the entry of the pipe so that the disinfected water is obtained at the exit. There is a proposal to increase the flow through the pipe to 22 mld from 16 mld. Assuming the dilution coefficient n is equals to 1, the minimum amount of chlorine to be applied to achieve the same degree of disinfection for the enhanced flow is. So in this question, they are telling that there is one pipe. So this is one pipe whose flow rate is initially the Q1 is 16 mld. 16 mld. Okay, and the Cl2 is applied at a rate of Cl2. Cl2 is applied at a rate of 32 kg. 32 kg per day. Okay, now and the length of this pipe is 2.5 kilometer as mentioned in the question. 2.5 length kilometer, diameter is 45 centimeter. This is the disinfected water. This is the disinfected water which is coming out. Now their proposal is that they want now the proposal is that the flow rate is increased to 22 mld. If flow rate is increased to 22 mld, then keeping the same degree of disinfection, how much minimum amount of chlorine is need to be applied. So this is another pipe. In this now Q2 is 22 mld. Okay. Now they are asking Cl2 is how much x how much x kg per day need to be applied, okay, to achieve the same degree of disinfection. So the basic concept is the in the disinfection process we have a relationship in the disinfection process. In the disinfection process we have a relationship like T, time required to kill the microorganisms, T, concentration of the disinfectant raised to our end is equals to constant. Okay, T denotes the time required to kill all organisms, all microorganisms. Okay, C stand for the concentration, disinfectant concentration. Okay, N concentration of disinfectant. Here N stands for the N. N stands for the dilution coefficient. Dilution coefficient. Okay, so this is the thing. So in the question they have mentioned N is equals to 1. Here assuming the dilution coefficient is 1. Since TCN is constant, we can write like this: T1C1 is equals to T2C2. In our case, N is equals to 1. Okay. Now C1. C1 in the question they have mentioned that initially 32 kg per day of COD, 32 kg per day is applied at the entry of the pipe, the chlorine, and the discharge is initially 16 mld. So C we can write like this: 32 kg per day by discharge Q1 liter per day. Okay. Now time T1 time required to kill is length of the pipe divided by velocity of flow. We can write like this: time to kill, length of the pipe is same, velocity will differ, velocity of pipe. Similarly here also we can write L to be same and V2 will be different, C2 will be, so the C2 we have to calculate C2. So the T1 C1 C is the concentration, and the question is asking the Cl2 which they have to apply to get the same degree of disinfection. So chlorine here is X. So this is what we want to know, this thing, and the flow rate is Q2. So we can write like this, like X divided by Q2 liter per day. Okay, and it will be in X kg per day. Since we have to find out this thing, now we can write the velocity as we know, like this Q is equals to A into V. From this we can write V is equals to Q by A. Okay, after replacing the V1 and V2 with Q by A, we will get L1 A upon Q1 into 32 kg per day divided by Q1. Similarly, we can write it like that, L A divided by Q2 into X kg per day by Q2. Since length and area is constant, so this will get cancelled, this will get cancelled. So we will be remaining with 32 by Q1 square is equals to X upon Q2 square. So we can write like this, X is equals to Q2 by Q1 whole square multiply into 32. After adding the value of Q2 will be, as mentioned the question, 22 mld, and the Q1 is 16 mld. If we substitute the values, X, the amount of chlorine will come out to be 60.5 kg per day. So this much amount, this is the minimum amount of chlorine that need to be added to achieve the same degree of disinfection which they are achieving initially. So the answer will be 60.5 A. Option A is correct. So